I'm so grateful to all y'all for coming here and showing up. I know there's a lot in competition for your time this week, and so I just really appreciate everyone coming to this session amid all of the other choices that I know you're having to navigate right now. So welcome. This is our session on bridging tools, looking at consolidating as we advance functionality in aim of meeting user needs. We've got folks from a number of different facets of ESDIS here to talk about suborbital specific perspective on tools. And I just want to draw your attention to the session notes. If I can go back to that one. So go ahead and fill in your attendance so that we can know that you were here, and thank you again later. And then also under our agenda, there are several links that may be helpful as we go through our discussion here today. So just know that that is available as well. We also have the Slido is open with like general questions. And we will start with a few polls, so please be ready to participate because we also have some fun Miro board activities that you just signed up for as we keep going. So, all right, let's come back here. So, right, science data users need nimble tools, right? So we've had this over many years, and for many very good reasons, have had this proliferation of a variety of tools that support all sorts of things, whether it's from data access, visualization, subsetting, and different pieces of particularly early science analysis. But it's kind of like when I had a computer for sending emails, and then you could use like a fax machine, and you had like this like digital camera when you had like 4 megapixels, you thought you were like the thing. And now like I have all of that and more right here. So it's not just that we need tools that do all these things, which those are all really great, but we kind of need to also move forward in being able to have tools that are nimble and can support not only different pieces of the research process in one discipline, but also be more, cross-disciplinary as science becomes more interconnected than we've had. So, I kind of have already talked about all this. We want to integrate these kinds of features and support different ways of doing science analysis, whether that is someone who still is this, wants to download everything and do it on their own local machine, or who is more comfortable working in the cloud. We need to be able to support those means of analysis as well. And then also conserve volumes, right? Because as that latter scenario becomes more and more the norm, we are more mindful of egress costs and things like that. And we want to support that in a responsible way. So I have the Slido, and I just want to hear see what some of your perspectives might be on what do you think of when you hear suborbital data tools, or what are science data tools, and kind of see what y'all's thoughts are. And I will leave that one for a couple of minutes if I can see it. Okay, tools that work with science. Yeah, well, okay. Oh, sorry. Thank you for saying that, Doug. Oh, so you can minimize that. This thing? Oh, I didn't know y'all could see that. You can hide that thing as well. Okay, thank you. All right, so suborbital. Okay, it says people are typing. Pretty visualizations. Yeah, I like pretty visualizations. So, hey, confusing. Yeah, I hear that. Fun tools that make it easier to understand. Yeah, these are all good. Any other thought? Okay. Yep, visualization, discovery, maps, flight lines. Yes. Temporal ranges. Yes, thank you for that one. Okay. We do have a few to get through, so I appreciate all of that. But let's also think about, what do you think when you hear tool consolidation? And you can also respond with emojis. which I think is pretty fun. So, can do that. What? That's a link. Oh, is it? Updated it. It's the same link. I just changed the which poll question is being asked. Yeah. Out with the old removal, great, hard to do. Yeah, painful process. Collapsing. Ooh. Efficiency. Oh, nice. So different kind of perspective takes on that. Could be good. Yeah, it's kind of a double-edged sword, right? There's like the good and the bad and the ugly, and it all has to happen to get there, right? Okay, very nice. And then we have just one more. This one might be the easy one. Or not, I don't know. If you know of any tools that reproduce functionality in some way, shape, or fashion, I have a guess at what that's going to look like. And I tried to make this so that you can get to all of these links in lots of different ways. So the Slidos, you have the QR code. I should have probably already said this. You have the link in the slides. It's also in the notes document. And then if you just go to like the Slido website and have that little hash, you can just type in Bridge Tools. It should get you to all of our little Slidos. So, all right. So let's see what that is. Oh, it doesn't. Let's see. I'll just pick one here and see how that fits in. Yeah, several oodles. Yeah, I've liked the word oodles lately. I don't know. It's just something that's been in my head. Okay, so here today we are going to be giving y'all a good perspective on several current and really widely used tools with suborbital data. Now, obviously, this is a bit NASA and ESDIS centric in terms of what we have here, but we welcome perspectives, and I think our discussion can be illuminate and also help, percolate ideas that apply not only within ESDIS, but also across agencies and other groups as well. So I will allow each of our speakers to introduce themselves, and we will go through each of their tools, and then we'll have some time after that where you can explore these individual tools or think about other tools that you use or have interacted with. And then we'll go through kind of a discussion exercise on a Miro board with lots of questions. And then at the end, we'll have like a small retrospective, which I think will be fun too. So without further ado, I will welcome Morgan, who will come on up, and we will start with the soot tool. And yeah, keep your eye on Slido if you have a question for Morgan, or she does have some fun things for you to do also. So thanks. Slideshow.
Hi, so I'm Morgan Silverman. I work with NASA's Atmospheric Science Data Center, and I'm going to tell you about our tool, the Suborbital Order Tool, or as we call it, SOOT. Okay, so SOOT is a data access tool. It was designed from science use cases to help enable findability and accessibility at a variable level. So essentially, it's a variable level search tool. If you're not familiar with suborbital data, it is highly heterogeneous compared to satellite data. So for example, one field campaign might have 3 aircraft. They might all have in situ and remote sensing instruments. There might be a mobile platform driving around on the ground. There might be a permanent ground station launching ozone sondes. Maybe there's a ship that went out to fly or to, sail along underneath the flight tracks. And then there could be multiple deployments in different years and different seasons. And then that changes from every field campaign to every field campaign. So it's a lot of data to manage and wrangle and deal with. So to deal with this at a variable level, we require additional metadata beyond what is currently in NASA's Common Metadata Repository, or CMR, and I will show you that later. So currently we have 26 field campaigns in soot. These are all field campaigns that are archived at the ASDC at the moment. And we have a couple different interfaces that I'll show you. So just as like a get us started, kind of see where we're all at here. In the Slido, can you please tell us what experience you have with suborbital data? I mean, is this the first time you're hearing the word suborbital, or are you an expert user in it? And then in general, no matter what kind of data you use, how do you prefer to search for your data? Do you search by variables? Do you typically search by a project name or an instrument? Or I'll let you all do that, and I'm going to keep talking, and we can come back to that. Okay, so as I said, soot is a variable level search tool. It searches across all 26 of those campaigns, and it's faceted, so no matter what entry point you come into on the search tool, it will filter accordingly. So I'm going to try and do a live demo, fingers crossed, and let's see how it goes. Okay. Okay. So this is the website. You can see it's automatically goes to the search page, but we do have a couple other pages that I will get into afterwards. So I'm going to type in O3 for ozone and see what I can find for ozone data. So down here, you'll get a variable selection list. It gave us 634 records, but clearly it's not all ozone data. And the reason for that is because it's searching through chemical formulas and descriptions and other search tools or terms. So if I go back up here and change it from contains to exact, it'll filter it down. And now we have just ozone data across all those campaigns. But you know, I'm a general user. I don't know what these campaigns are. I don't know where they are. So since we're in Texas, let's see if there's any Texas data. Go up here and I'll draw a box over Texas. All right, so now we have some campaigns that come up, and this is essentially any campaign that has a flight line that goes through the box that I drew. And if you hover over the different campaigns, it'll highlight which ones go to which campaign. So we select campaign, and once again, it filters, and now I only have 42 records of different variables. So I will select some ozone data from the aircraft. And I apologize, for some reason it's being really slow recently, so I have to go back and ask about that. There's only one variable here for ozone, so to make it interesting, let's search for some other data. We can add NO2 and add that and add some more variables. And as I add them, they should be placed in the shopping cart, which is at the bottom. And you can remove things if you change your mind, add more things. And if I had selected multiple campaigns, you would get different tabs at the top here, and it would look the same under each one. So you can kind of do multiple things at the same time and not have to always start back over, which I think is a nice feature. You would then review your variables, and here you can select dates. So these are all the dates that go along with the campaign. You might know there's one event that happened on a specific day, and I only want the data for that day. So you could choose what you want here, and then you can decide, do I only want the data files? So you would get essentially the raw data file that contains that variable. We don't pull the variable out of the data file. We give you the whole file. Or you can merge the variables, which I will explain a little bit more later, but I'm just going to quickly show you how to do it. Essentially, merging is kind of taking those different data files and averaging them into a single file on the same time base. So in a lot of times in like in situ measurements, you might have like 1 second data, you might have 10 hertz data. It really can vary. And so this will kind of put it in one file at the same time and get your analysis started without you having to do all of that processing yourself. So you can choose that for each of your platforms, and then you would merge and download the data. So it's kind of a quick overview of the tool. Let's see, go back. Okay, so as I said, at the top here, we have search. We also have a browse interface and an API. So this is what the browse interface looks like. It shows all 26 campaigns. This was really designed for kind of like a science team or someone who's coming in knowing exactly what they're looking for. You can go directly to that campaign and specifically choose like the data you want. It was designed based off the field data repository that we run at Langley. So this is, after you choose a campaign, this is what it looks like. You have your different platforms, your investigators, and your different data IDs. And then if you were to expand the principal investigators on the right, you would see all of the data files listed. So this gives you the option to choose either a few variables for all flights or all variables for just one flight. So it does something similar to the search, but if you know what you're looking for, sometimes it's easier to just come in and grab it and not go through the whole search component. So as I said, the merge essentially creates analysis-ready data products. We are averaging the different data sets based on their native times onto a single time base of your choosing. We do this through weighted averages, and it's a highly requested part of our tool, and it gets a lot of use from what we've seen. So, okay, we also have an API. So if that's your cup of tea, you can come in, grab your data through the API, and move on. I am not a developer, so this means nothing to me. But if you are, this is what it's based off of and how it runs. And I will let you read through that and not discuss it at all. Okay, so as I said, this is variable level search, so we need variable level metadata. We have our own on-prem database at the moment. This is essentially all the metadata that goes into Soot, and the ones that are labeled D are just for discovery, and the ones that are labeled M are for merge. So there's a lot more metadata that you need for the merge than just to search for a variable. The way the variable search works is through obviously the search term, but then that is matched to our atmospheric composition variable standard names. And we created these essentially as a tag so that no matter what the PI names their variable, we know that ozone data is ozone data, and we can find it across all 26 campaigns. Within the database, we also have aliases and chemical formulas and definitions. So all of that can be searched at the same time. The only thing we don't actually store are the LOD flags and missing data flags, and those we pull directly out of the files at the time of the merge. Recently, we've been working a lot with Loyola University and some of their undergrad classes to get more like general user feedback in terms of like, does the search tool work well for someone that just needs to know, I want data over Chicago. Do you have any? And so that's been really fantastic feedback, and we'd love to work with more universities and classes to get more feedback. So as expected with any tool, you get a lot of, we want this and we want that. So some of the desires that people have that we hopefully can get to in the future are an expanded merge service to include other formats. Like right now, everything is iCart format, so we don't output anything in NetCDF, but that is probably the top of the list for people. To include uncertainties, have more consistent variable lists. As always, user interfaces and map enhancements are big requests. People want different colored flight tracks, which I totally understand, to show data on the flight tracks and other things like that. People would love to see different preview and plotting tools and different readers for the data before downloading. It's kind of a nice feature to kind of get a preview before you actually download the whole thing. And then just additional documentation. So hopefully we can tackle some of these in the future. So just to finish, a few Slido questions. What feature of Soot would provide most value to your workflow? Is there anything that really jumped out at you as like, oh, that would be great to have, that we don't obviously have included right now? And if your data was in the tool, would you use it? And if it seems like it's something you could use or would use, what kind of data would you want in something like this? That's it. Thanks.
Thanks, Morgan. That was interesting. I was curious. So I know you mentioned that the merge function was like popular from what you could see. So it triggered some questions for me around like metrics and how you're gathering it. And I'm just curious if you're able to see like specific functions, or even like, of course, I'm a metadata person. So like what metadata aspects are kind of the most important in the tool, or if it's just all of them. Are you able to see that level of granularity in like what the users are doing?
No, I think is the short answer. I know we've been trying to collect more metrics. I don't have all the information on that. Other people have done that in our group. But I know they've struggled with what level of data they can get, because you have to be logged into Earth data to do some of it, I think, because it's connected. So that limits some of the information we can get. A lot of the metrics from the merge come from the data repository that we run, which was the kind of the original site of the merge. So we know how many people were using the merge there, and we were trying to slowly move them away from the repository into more of a DAC, role. With regards to the metadata, I think it's all important. I mean, variable level metadata is a whole, can of worms in itself. So I think it just depends on what level you want to do. If your discovery is your goal, then you don't need as much. But if you want to do more detailed analysis with the variables, then you have to include a lot more information. So it kind of just depends on your goal.
Thanks.
Thank you.
This is Xiaohua from NASA Justice. I will ask this question from user perspective. I have used the fire EQ field campaign data. For me, I think the challenge is how to, co-locate the field campaign data with other data. For example, you want to validate the model data or let's say satellite data. Mm-hmm. So is there some tool help users to regrade the data? Like in terms of temporal and the spatial, like vertical height unit.
Yeah, no, we don't have any of that right now. It's especially locating the satellite data has been a big request, and somehow how to match that, but it's not something we've had time to really look into with this tool specifically.
Thanks so much for sharing about this. I just had another question about the merge. Mm-hmm. You mentioned it averages it somehow. Mm-hmm. Is that based on, how is that based? And can a user change that? Like if they have an algorithm that they think is a better merge, or is there just one kind of way?
Yeah, the merge itself is coded into our thing. So the only thing you could change is what time base you wanted. I mean, essentially it's taking the times from each data file and then whatever you've chosen, and it's using a weighted average, kind of how they overlap. But you can't change. Yeah.
Great presentation. You collect spectral data with this, yes?
Yeah, if it's from a remote sensing instrument that does that.
Okay.
Yes.
Do you have tools that can convolve the spectral resolution between different data sets to make them easier to compare?
No, all we can do is basically give you the data. So we can't help you with any of the analysis of it.
Okay, thank you. Mm-hmm.
It's been mentioned that it's about, are there plans to integrate Soot into Earth data search?
Well, that's well above my level. But I think there was this talk about tool convergence. It's been discussed for a while. It's kind of where all these tools have landed in a way. And I think, I don't know what the idea is going forward, but I think that the thought was, is there a way we can combine some of these tools together, or are they too different? I don't know where this is going, but yeah.
So yes, good morning. I am Jeffrey Stano. I'm representing the Global Hydrometeorology Resource Center, the Distributed Active Archive Center. I'm serving in the role as the DAC scientist. So I get the opportunity to work with all the various folks through there. By trade, I'm a meteorologist, but I'm living in the computer science department with most of the developers. So it's a fun opportunity to interact with people with others, lots of unique skills and capabilities. And it's been a very fun experience to work with them on the FCX system. And so I've a couple of the individuals through here. Obviously, this is not going to happen with just me alone. This is a lot of their work, so I have the privilege to present a lot of their efforts here as well. In terms of just what I want to talk about today, I'll give a little bit of background about JHRC, and then really kind of, since you're hearing from 3 different DACs here today, to kind of a general overview of where we are. I'm going to sneak in a second tool talking about Panda, which is something for data access, and really start talking about some of the issues that we're facing and what we're trying to address with this. This talk is also very similar to the talk I gave earlier on Tuesday during the real-time session. So if you want to see some of that as well, you can check that out also. So we're looking at NASA's Distributed Active Archive Centers. There are 11 of us scattered across the country. We all have kind of unique specializations, but there is a lot of cross collaboration, if you will, in terms of the types of data sets that we work with. I mean, you already heard from Morgan. We're going to hear from Rupesh in the next talk. And we're all kind of organized with working with these suborbital data sets. So there's a lot of familiarity through that. Now, our mission is really to kind of serve as the public-facing location for where you can get NASA's Earth science data. It's meant to be freely available so that individuals can get to it wherever you are. It could be domestic researchers, international partners. That is the role of the DACs right now. But as we go forward, just kind of letting everyone know also, this emphasis is also on science enablement. We want to make sure the data is available for you to do the research, and we are kind of evolving. We're moving into NASA's science enabling teams, kind of focusing on the various NASA spheres. And then also you'll hear a little bit about the group today, kind of the grouping of the atmosphere or the suborbital related DACs working to support the suborbital archive readiness group or the SOAR group. So kind of those are all the little organizations that are out there right now. So one of the things that we've talked about when we're looking with these data sets, there's the question about data access. So how do we get hold to the data? Well, when it's formally published, you go to Earth Data, you can find it in Earth Data Search. That's fantastic. That's where we want you to go. And then the process of actually archiving data sets, it takes some time. The campaign takes place, PI starts sending data to the various DACs, and it takes time to start processing that data. The problem is that when you're, during that time, the PIs or the data users, they need to have access to the data. They need to be able to have a DOI link to access for journals or for conference presentations, things like that. So we've developed this kind of local tool called the Pre-Release Access to New Data Accessions, or PANDA. Essentially what it is this is an informal location that we can take data once it's been given to us. We put it into the cloud. It's public facing, but behind kind of NASA's own kind of security and everything like that. And we can assign a DOI link to it. So this allows users to kind of start referencing the data before we've formally published the data sets. Now, it's understood that, okay, we haven't done any quality control and things like that, but this is kind of a unique way to kind of make sure that access is available. And this is one of the things that we're looking at kind of coordinating with Sauron to kind of expand it out beyond just GHRC. Now, as we heard in Morgan's presentation as well, we have lots of different data sets that we're working with. It's airborne, satellite-based, ground-based. It can be point data, 2-dimensional data, 3-dimensional data. How do you try to bring all of that together? So that's kind of one of the issues that we're facing. And the images that you see here, this is kind of showing a layout for a field campaign, showing all the different instrumentation that was deployed for that one location. But at the same time, too, many times you're working with satellite data. These suborbital campaigns are serving as the ground validation for the orbital campaigns. So how can we work with all this? So we start getting into these operational issues that we're trying to combine all these multiple types of data sets and try to visualize them, analyze them, and work with them. And the neat thing about these suborbital campaigns is that they bring together lots of different experts in their field. You're bringing in lots of different instruments, expertise, and what we want to do and need to do is be able to start capturing that expertise. How do we start visualizing those data sets? How can we visualize them coincidentally? And also, how do we make sure that we can make the data sets kind of accessible for analysis? And so you need to be able to start kind of bringing everything together in that three-dimensional sense. And so here we have the ER2 flying along, showing us some previous data from the cloud radar system. These red lines representing the electric field within the clouds, things like that. So the FCX system, as previously known as the Field Campaign Explorer, was designed as a potential solution for this. So what is it exactly? In short, it's a three-dimensional data exploration tool. So it's meant to let you go in there and kind of say, okay, what type of data do you have with this campaign? Can we visualize the data? How do we get information about the campaign? Also, you may not be familiar with a particular instrument. So what about documentation for those various instruments? What we've tried to do with this is that we've focused on making this open source and cloud-based. The open source is because at GHRC, we're a small group. And we're working with a number of campaigns, but as you can see from the previous presentation and the subsequent presentations here today, there's many more campaigns that are out there. So if we just kind of limited it to just us trying to kind of visualize all these data sets, we'd never get through everything. So the idea is to make this open source so that users can come in and say, hey, I can work with this. I can put in my own plugin to FCX to visualize the data and kind of bring it all together. Cloud-based was important for us as well because our data sets have moved to the cloud. And that's been one of the major emphasis for ESDIS as well, is kind of moving the holdings into the cloud, not just GHRC's holdings, but all of the NASA holdings. So we want to make sure that we have these cloud-native environments for FCX to work. So the nice thing about that is that means you don't have to download any any kind of software onto your system to get this to work. So what I'm going to do here for some demonstrations, I've kind of saved some videos through here. I wasn't quite sure, didn't want to risk it in terms of trying to switch over to other systems. So we got this through here. And what you can see, we're looking at kind of this nice display here. We have the ER2 flight tracks. That's the little lines through here. We have a nice little graph of the ER2 here. This curtain is the cloud radar system. We're looking at those field lines for the electric field. And as you can see through here, you see the mouse kind of going over and kind of pointing out and pulling up observational details from the satellite-based International Space Station Lighting Imaging Sensor and the Geostationary Lightning Mapper. The other thing, too, is this is kind of based on a cesium platform, so you have a dynamic view as you come in. You can see things as you zoom in and zoom out, kind of make it easier to try to display data sets. Kind of another perspective of this same thing. I'm a lightning scientist by trade, so I had to bring in some lightning data through here. This is looking at, you see through here kind of similar, you saw the cloud radar system, the flight tracks. This is a ground-based lightning mapping array. And this can show the lightning observations in 3 dimensions. So you can look at individual lightning flashes. And what's nice about this is you can see that 3-dimensionality in relation to where the radar data is located. You can see how radar is evolving with the lightning activity in that particular storm. And kind of serving as a background right now, we have the Advanced Baseline Imager, kind of a space-based kind of showing what is the cloud structure looking like through there. And as you kind of see through this, we have the various we're clicking on various things. You're seeing things move along. You can toggle data sets on and off. Up here in the upper left, you could click on that, get information about the campaign itself. The data link through here, you can actually use that to start looking at the individual information for each instrument that was associated with FCX. There's also a little subsetting tool. I don't have a video of that, but you can actually just put a box over the location and it will just grab all the data from that particular box. In addition to, we don't need to see the video again, but in addition to, one of the things that's helpful is this little timeline tool. This shows where all the data sets were active in time in this particular display. So in particular, this is very useful when you're looking for satellite overpasses. That's a very singular point. You may only last for about 90 to 120 seconds, and you want to know when that's going to occur in relation to your other data sets. And again, just kind of showing a couple other observations. This came from a National Science Foundation funded project, the Lake Effect Electrification Field Campaign. And what's interesting about this is that this is showing a radiosonde, or kind of a weather balloon launch. Operationally, we typically visualize these data sets from we just assume that the balloon goes up and stays directly over the launch site the way we display it. In reality, we see that does not happen. You actually can see how the radiosonde is moving in time to a different location. As kind of a fun aside from this, I got to participate in this campaign. If you'd ever expected me to be snowshoeing in the backwoods of upstate New York looking for a radiosonde instrumentation that had been dropped, I would have been highly skeptical a couple of years ago, but that's what I wound up doing. So field campaigns are exciting. The other nice thing too is, again, I've liked this too. This is actually, we saw the ER2 pass through here. This is a drop sonde. So basically the opposite of a weather balloon. You're just kind of literally chucking it out the back of the airplane, and it kind of floats down, and you can see the track of that, which is very interesting, seeing that three-dimensional view. But also, as we kind of zoom around, you can actually click on that location and then show the profile of the temperature and dew point and the humidity from that particular case. So we're looking to kind of improve these analysis capabilities as well. Can we do more than just simply visualize data? How can we start adding in the analysis to these data sets? So where are we going with a lot of this? As I've mentioned, we're trying to work on capturing the expert's knowledge. And we want to be able to kind of use what they've done. So these scientists, they've created their own visualizations. We want to try to capture that and bring that into the FCX system. What's also nice about this is that within the FCX system, you can take those visualization pieces of software, pull them out into Jupyter notebooks. And this is what we're showing right now. This is the animation from a Jupyter notebook. And what's been nice about this is that previously we had integrated this within the OpenScape system that provided a kind of a community-wide set of Python libraries. And that has been very helpful because I hate to say it, but Python libraries are the bane of my existence. Trying to ever get them to work is not a lot of fun. So being able to give users a Jupyter notebook that they don't have to do anything other than just run it is fantastic. And what I'd like to see this as a data recipe. So they can take this notebook, they can see how they can crack open a file, look at that, and do a simple manipulation with it. And so to kind of wrap up here, we'll go to the last slide, Norm. Doesn't want to go to the next slide. Okay, well, it's the show that never ends. So I'll just mention here. So basically at the very end here, what we are doing now going forward in the future, we are going to be working with the investigation of convective updrafts mission. This is a kind of a small sat mission. They are going to have, in addition to the satellite observations, they will have some ground observations with it. They have a pre-campaign that was called Time Slice, and then they will also have a post-launch campaign called Pi Slice that we'll be working with. We're integrated with their science team, and we're trying to work with them to learn what they want to see out of FCX as we go forward. In addition, as you've heard from Morgan's talk previously, there has been some discussions of how do we potentially bring SOOT, FCX, and these other tools together in part of this whole tool convergence. And so we want to kind of see if there are ways to kind of do that to leverage the strengths of each group's tools. And with that, thank you for your time and answer any questions.
Luis from NSIDC. Thanks for the presentation. It was really cool. One of the things that is kind of like interesting to me is like, it was like a plug and play with Cesium, or you had to massage the data to have like these cool, amazing animations?
We've had to massage the data a bit. Part of it is that we're working with data sets that were kind of in this campaign compliant format, so HDF, NetCDF, things like that. But we're having to move them into these cloud optimized data sets, ZAR, COGS, or the cloud optimized GeoTIFFs. So that is one of the slow points for kind of this transition. We can pick up the data sets and run with it, but we do like to try to get it into the cloud optimized formats.
Thank you.
Thank you.
Oh. Get my steps. I wonder if we have folks online, Pat. So
Jeffrey,
Yes.
Pat from CDDIS. So how do you quantify the cost versus benefit analysis on this tool? How many people actually use it versus how much it costs to do it? And how do you say we spent enough money to do it or it wasn't worth the cost?
Those are good questions. I don't think I have all the answers. From looking with some of this, the number of users that are working with this at the moment, so far it's fairly limited. We've been trying to get this expanded out to other users. And that's where I think some of the discussions that have occurred in terms of how do we potentially link this in with some of the other tools that are out there. So that way they're not all kind of individual capabilities. I would say it's been fairly kind of a low level effort in terms of funding. That we've taken this out of kind of some of our core funding. From in times past, we have had individual directed funding that we've earned through proposals and things like that. So overall, the level of total funding has been fairly low, I'd say, for the project. We're still working to kind of expand the user base for it, though.
So right now you have GHRC data.
Yes.
But we're moving to a set kind of
exactly
structure.
Yes.
So other atmospheric data, suborbital data, how much effort is it?
I think what we want to do, we want to find a way to better automate the process to get the data sets in there. One of the things that we've encountered as we've tried just working with the GHRC data sets is I'll pick on the Cloud Radar system, which is again airborne radar. It's been deployed many times, so it's available across many campaigns. So it's a great candidate to transition into this. The issue that can come up is every time it deploys, there can be some tweaks to how the instrument works. And again, this is nothing wrong. I mean, technologies evolve. They come up with new and better ways to do things. But that means that the actual data set that we get is not quite the same thing. So it requires kind of that human in the loop to figure out what is different. So I think in terms of where we're going, I think we want to find ways to automate the process a little bit more. We've asked ourselves, can we potentially have like an AI extractor kind of work with that? And I think also as we go forward with trying to integrate with the rest of the airborne DACs, kind of leverage their expertise. They likely have their own visualization of data sets. How do we bring all that together?
Super awesome. Makes me very sad that I'm actually not working with any of these data. But I'm wondering, and maybe tying back a little bit to our discussion yesterday on Earth Access.
Yes.
So this is free and open source software on GitHub. Is there like a clear plan of how the development, how the support will continue into the future? And will there be possibilities for upstream development, like pull requests from forks into that? Is that a general thing that...
That's a good question. I think we need to kind of really determine what that workflow is going to be. It has, as we were kind of mentioning with the previous question, this has been kind of a low-level ad hoc effort as we keep going forward. And I think we need to kind of better define how that's going to go forward in the future, particularly with ESIS 3.0, the transition to the sets, things like that. So I think that's an open question, how that's going to come together. But it's a good question. So yes, we are thinking of that though.
Just to highlight a question about SOOT that's related is considering open sourcing the code so that community members can contribute pull requests. So I think that's
yes, yeah, we're open source right now. So yes, and I think there is one question in the back as well.
Awesome.
John Liu from Justice. So field campaign data, suborbital data are very important, but my feeling is that user find this data set not easy to use. Is there any way, since we have Earth data search and Harmony, is there any way we can upload this information or maybe select from some kind of list, to subset, data from other satellite missions like, train GPM,
No, that's excellent. We are making sure that we're kind of connecting into where the data are located within Earth data. So that's important with again, with GHRC data sets that are uploaded. I mean, my grand vision would be that if we were to kind of cost is not an object, times not an object, things like that, if we were to do all this, I think what would be exciting would be able to have this merger with like what we're seeing with Soot, being able to kind of look at the metadata, because Soot has the ability to say, oh, you're looking for this instrument. Here's all the instances of this instrument or this variable. It would also be great to be able to go into Earth Data Search, say, I'm looking for the data set from the ER2, and that you find it, and then it provides you with, hey, here's the visualization for it. Again, is that going to be FCX? Does that evolve into Harmony, Worldview, things like that? That's kind of the open question, but that's definitely where I would love to see it go, that it becomes kind of a capability, so that not only do you look up the data and say, okay, I'd like to download this data, I can now see a sample of the data or even the entire data set in some way.
Thank you. Sorry for that. So my name is Rupesh Shrestha. I'm with Warner DAC, and Michelle Thornton, our Warner DAC manager, is also here. So I'll be talking about a tool called TestFish. It's another new tool. It's been around for a while, but we have renamed it so that it works for subsetting and visualization for terrestrial ecology, and also specifically for the suborbital sites. So that's so I created this graphics from ChatGPT, but it did a good job like showing the range of suborbital platforms that is up there. That could be the range of things, but we would now primarily focus on the suborbital sites. So this could be like permanent sites like flux tower nets, flux tower sites, or long-term sites like Neon or LTER sites. So these suborbital sites usually collect these continuous data sets from their instruments, but they also want to co-locate where the sites are, and then also compare their data sets with what you get from the orbital missions, right? So here is an example here where a flux tower collects net ecosystem exchange rate, and then they also want to compare that with how MODIS does with the MODIS and DVI compares with the net exchange rate, for example. So this kind of this kind of comparison between suborbital sites and also this mission data sets coming from the orbital sites is fairly common in these community. So they can be mainly for the CalVal or for other reasons as well. So there is a need of a tool that can do this kind of analysis fairly quickly, like bring suborbital data sites and bring the mission data sites from the orbital sites fairly quickly together, so they can do their those comparisons. So here is where the TestFish tools comes about. So TestFish tools provides this very easy to use format for those sites. Like, so all these site-based researchers can come and get those data sets. So TestFish tools is a suite of 3 tools as of now. So there is a tool called Global Subset Tool, so where users can come and select a location, and then also select a time period and submit the order. And they will wait until the order is processed. And when the order is processed, the user will get an email that, hey, your order is ready, and come and get it. And so that period can be like overnight or over lunch, like so here. But if the area is fairly big, and then there's a long queue of the users waiting to get their order submit, it would go like a couple of days as well. But for the fixed size tool, what we have done is like we have chosen these 3,000 plus sites. Now I think there are 3,700 sites from these flux towers and other LTER. And then we have pre-processed these subsets and put them in our database, so the user can come and get those subset data instantly. So the fixed size tool gives the data in immediate range as well. And we also have this web service that also gives the data, those subset data sets, so you don't have to wait at all for these data sets. So these are some of history. So we have a kind of long history with the TestFish. It's been around for almost 23 years now. So it started with just 169 FluxNet sites, where we created this Modis cutouts for collection 4. So and then Modis now is in collection 6, and Modis 7 is coming about, and we still are have added a lot of features and stuff on the tool as well. So during these years, we have also make sure that a lot of users are still using it. So these are the statistics, usage metrics from the last 5 months. So as you can see, like every month, like thousands of unique users comes to the tool, and they submit the requests in millions. So a lot of users. So this tool has been fairly popular over the years, and we also have some record of the citation that people have cited. So far we have found 771 referred citations. There could be more, and then the figure in the left here shows like how much the journal impact factor is for these publications. So I think the average is around here, like 4.5 impact factor. So there are a lot of high impact factors journals as well that has used the tools to do their analysis and publish the paper. And the right figure here shows how these publications are categorized by Web of Science categories. So as you can see, like folks in agronomy to water resource to environmental science, they have all published their manuscripts using the tools for their data analysis as well. So we'll focus on the fixed size tool for today. So fixed size tools provide these subset data sets for a range of sites, so that are across 130 countries and covers 51 networks. So networks could be like Ameriflux networks, Neon networks, LTER, and so forth. And so if you go to this site, then you can also look for the documentation and other API documentation there as well. So this visualization, if you click in one of the green dots, it'll land you to the page like this. So this is a page for a single site. So this site shows a subset data for this California Tangi Ranch. So here in the top, there is a visualization where you can get information on the coordinates of the site, as well as other network that the site belongs to. So this Tangi Ranch is like kind of very widely studied sites. So they have a lot of instrumentation there. So as you can see, there is also Phenocam installed in that site. So you can click this link and then go and get the other data sets as well. And then down below here, there is a table where you have all the products that have the subset available for this site. So if you click one of these links, then this page will show up where you can go and download the data in a simple like CSV or JSON format. So there is a column for downloading the data, the raw data as it comes out of the file. And also for the selected bands, you can also get a quality filter subsets. With the Modis and VIIRS, quality filter is very tricky. So you have to navigate all the bits of these pixels to find out if the pixels are cloudy or the instrument is not giving you the real data sets. And so we have worked with the Modis science team to figure out what is the default range that you can apply to these pixels. So you'd get a quality filtered values, so they can filter out all the bad pixels data sets for their downstream analysis. And there is also a summary data sets that you can download that will give you statistics like mean, median, and all values as well. And we have these two visualization, one for the time series and one for the grid. So this time series visualization is very useful for a lot of applications. I've seen people come and grab these screenshots and then put them in the poster and present in the AGU. So a lot of people even don't have to download this data set. They can come and then just get the visualization they need and present their results as well. And this in the grid visualization, you can just click in these grids and get the pixel value as well. And we also have this widget, which is a JavaScript that you can embed in the website. So a lot of these suborbital sites have this PI. They want to display these time series in their websites. So we have seen one in this Ameriflux websites where they have just used these scripts to display the test space visualization in the website very easily. And there is always the citation as well. We have the DUI for these data sets. And then we have this web service as well, which gives you data in the CSV and JSON format. And so this REST API is use the open API specifications, and it's very easy to use. And we have also a lot of learning materials here in this section where we have done webinars in the past, and then other Jupyter Notebooks tutorials as well. And other folks and community have also used the API to build their own modules, like R modules, Python modules as well, which has been widely used as well. And then we have this graphical interface where user can come and test their service, the codes and things like that. So these list some of those endpoints that people can use, like how to get the subset, how to get the filtered subset, and then subset statistics as well. So this is one example of how the output from the API looks like. So if you request the sites endpoint for the AmeriFlux sites, then you'll get all these AmeriFlux sites that are in the tool, and you'll get coordinates and then a link to the AmeriFlux sites as well. And then if you want a subset, then you provide the start date and the end date, and then you provide the product name, and then you get a response like this in JSON format. You can also get this in a CSV, but the JSON is much easier for the programs. And then if you look here, the data has this comma separated values that programs can easily grab and make use of these. So if you look here, so this is from 2003 to 2013. So this is 10 years worth of data that comes back very instantly. So if we were to process these, like, so 10 years of the Modis 13 Q1 is like, so they have one file for every 16 days. So 10 years would be like hundreds of files you have to hit to get these results. But because these are the pre-processed data sets, so you'll be able to get that very instantly. So here is one example where you can use this API to produce results like this, like here, a plot of like 634 sites. To get a plot like this for all these Modis and VRS products, you'll have to hit a lot of files, and then it will take a very long time to get these kind of outputs, which you can do because we have this API available. You can do instantly. And then there are some notebooks here we have developed. Please go and check them out and let us know what you think and what other features you would like in the tools as well. And also there is tool consolidation going on as well. So yeah, that ends my.
Hi, I'm Ronnie from OpenEscapes. That was a really cool presentation. Does the app tries to match the pixels from Moody's to the tower flux footprint in some way? Like, because that's some of the things that is kind of like hard to match.
Yeah, so the Moody's comes in a scene grid, a sinusoidal grid format, right? So these data sets usually are in a long lat. So you have to do some conversion there to get into the scene grid. But it's not that hard things to match. But so the issue with the Modis is like, because the Modis data sets are tiled, sometimes your site falls in like multiple tiles, and then you'd have to grab like all the tiles and also make sure the subset data are well done. Like, so that can be sometimes an issue, like tiling these multiple tiles into one.
But that's something that the user has to do.
Yes.
Like the app in okay.
But if they use these tools like TestSwiss, for example, they take care of those things, and users don't have to worry about the tiles and all that, right? So they'll just provide how big the area they want, and they get that already a single tile subset.
Oh, thank you.
Hi. I'm Doug Newman at NASA ESDIS, the Goddard Space Center. Yeah. Okay. So I'm going to talk about suborbital Earth observations and Worldview and Gibbs. And every single conversation I've had with Stephanie about suborbital has made her want to tear her hair out. And similar situation with Worldview and Gibbs. So I don't know why I'm the one giving this one, but let's give it a shot. So we're going to talk about Gibbs and Worldview, what they do, functionality associated with both of those applications, how you can access imagery through Gibbs, and how you can visualize that imagery in Worldview, and finally, what Gibbs and Worldview does for the suborbital use case. So, ESDIS's core mission is to ingest, archive, and distribute science data. In distribution, we have the concept of discovery. In order to distribute that data out to our user base, they need to be able to find the data they're interested in. And Gibbs and Worldview solve that problem with a visual first approach by enabling users to look at representations of that data through various tools to determine whether that is the data they're interested in. So on this slide, you can see science use of Gibbs imagery using Worldview. You can access Gibbs data through geographic information systems like QGIS and ArcGIS Pro, and various commercial entities have leveraged the Gibbs imagery archive to produce their own products. We have an example of that at zoom.earth at the bottom there. So Gibbs is a repository of visualization layers. We've got about 1,000 full resolution visualizations in the system. Many of those visualizations have what we like to call a near real-time latency associated with them. Things like fire detection layers that can be visualized within 3 to 5 hours of recording the data. Worldview is a user interface on, initially it was on top of Gibbs, but it can now pull in visualization layers from other sources as well, providing full resolution imagery for the entirety of NASA ESDIS missions, some within 3 hours of observation, as I mentioned in the previous slide. You can compare two visualizations that can coincide either spatially or temporally. You can make animations of various visualizations or snapshots, and you can use the knowledge you've gained from those visualizations to go on to get the data associated with those visualizations using smart handoffs to Earth Data Search, which is the pillar of our discoverability core mission using visualization first. So what can Gibbs and Worldview provide you? This is a brief description over a variety of dimensions: format projections, 2 types of visualization, raster imagery and vector data, which is important for suborbital, which I'll get to later. Spatial resolutions ranging from 300 to 375 meters. Temporal resolutions from 6 minutes up to yearly and everything in between. Latencies of 3 hours from data capture for near real time, longer for everything else. I don't know what 40 minutes for geostationary is. If you have any questions about that, Ryan Boller. I'm just his proxy right now. I thought I was doing well until I read that sentence. So if you didn't know already, a data visualization is not the actual data. It's a representation of that. So it's good for light analytics, but it isn't the full precision data. 2 types of raster-based imagery: the opaque base layers, which you will probably be familiar with when you go to Worldview, this blue marble-ish type image, which is interpreted as is. And then you can add layers over the top of that with various transparencies to do your lightweight analysis or evaluation for moving on to data acquisition. And then we have our vector data types, points, lines, and polygons. In this particular example, we're looking at wildfires, but as I'm going to show you later, it's very useful for showing the tracks of airborne campaigns. You can access the Gibbs imagery through your favorite GIS system due to the fact that the Gibbs API supports some standards-based protocols, WMS, WMTS, XYZ. The Z stands for Zoom. Didn't know that until I read this yesterday and decided to do some research on that, but neglected to do any research on geospatial 60-minute or whatever it was. So this is some examples of layer visualization in QGIS, I think, but you can also use the Esri ecosystem for this. You can use GDAL and other map libraries and Python to access these endpoints, as I mentioned, WMS and WMTS, etc. And moving back to worldview, you can do all kinds of very impressive stuff on worldview. Don't tell Ryan I said that. You can make animations, GIFs, do snapshots of imageries. You can provide geotiffs and KMZ files to your favorite GIS client. And you can use that nice slide comparison, which you've probably seen in various commercial websites, because you can embed worldview views into those websites. You'll have seen it on places like CNN, BBC, etc. Because of that, worldview has a rather large user base. For the amount of money we spend on it, Pat, we get gazillions of users. So the cost efficiency of worldview is off the map. You can also look at visualizations with respect to various events that happen. We've got a hookup to the EONet service so that you can browse through events and see visualizations associated with earthquakes, volcanic eruptions, tsunamis, etc. You can download the data by taking the context you've built up in worldview, spatial temporal filters, particular layers which maps to data sets, and go directly to worldview with that context intact and just get on with that the data. And finally, that light analysis that I talked about is the charting mode, which is still in a kind of experimental phase right now, which will give you a limited amount of the data, the information from the underlying data, mean, medium, minimum, maximum, etc. And we've had anecdotal evidence from some organizations that minimal amount of data is sufficient for the use cases they're working on. So they don't even have to go and get the original data. They can just stay in worldview for their analysis. And the meat of this talk, suborbital, my favorite topic. Over the last year, the suborbital community have been working with Worldview and Gibbs to visualize their data within this ecosystem. They have 9 missions available right now. They are itemized on this slide, but that ability to do vector plotting is what makes this all work. Here is an example in QGIS. It looks like somebody's just drawn a marker over the over that base layer, but I assure you that's a flight track. And this is also available in WS, which is how QGIS consumed this data, and you can find it in Worldview too. And it looks much nicer in Worldview, I think you'll agree. Any questions?
Okay. So we were going to have y'all kind of play with each of those tools at your time at your own time. And there's links to that in the document if you aren't already semi-familiar with them. So we have a few questions. And so in there, you can link to the Miro board. And then we have some questions set up for you to answer, like where do you see overlaps? I'm sure you all have examples of that. And then additional things. What is most desired? What do you think is most attainable? What are some of the back end and technical sort of implications of both of those answers? And then what makes a tool nimble? And if there were sort of one tool, your wizard hat on, what does that do? What does it not do? And you can take that in whatever direction you want. We want your kind of open-ended input there. So feel free to jump on into the Miro board and you can kind of zoom in and out. I can't do this with my hand, and then grab a sticky, and those questions are all here on the board. So go ahead and fill in your thoughts. And while y'all are doing that, there were a couple of, okay, now I'm going to try to share just one tab. So there we go. As y'all are doing that, there was a question that I wanted to, from the Slido, and this is, I'm really glad Sarah is here also. The question is there a vision from ESDIS on how users should discover data, navigate, connect to appropriate tools? As Earth Data Search and Earth Data seem to address similar needs, and the individual tools for access and visualization seem to address specific use cases. So,
I mean, we have Doug here, and I think Doug has a vision.
This is where I go. I saw Chris walking in here. We have an existential problem in ESDIS in that our data is increasing exponentially and our budget is not. In fact, it's quite flat, and who knows, it might get less. So consolidation is one of the ways, or the primary way, we're going to be able to achieve all the wonderful things that everybody in this room is doing with that limited budget. So the tension there is what we can afford to spend versus what functionality either needs to be consolidated or left behind. Consolidation is preferential to leaving that functionality behind. But what you're going to get is a one-size-fits-all scenario where we try and get as much as possible into a subset of tools and services, but we may not get everything in. And Chris isn't waving his fist at me, so I think I did all right there. Chris, would you like to add anything to that?
Sure. So I think the question is what are we going to do with all the tools that we have? Is that pretty much the gist of the question?
Yeah, I thought so.
Okay, so we have a lot of tools. And if you've noticed, at least I have noticed sitting here through a lot of these sessions, is a lot of the tools actually have a boundary box of what data they can pull in. So a lot of the tools were built around a data set, and then other data sets were brought in as they could. If we're going to go to multiple source sites, meaning you're going to go across the entire archive, I don't actually think our tools today can do that. So we've talked about tool convergence. I'm not a big fan of tool convergence because that means we pick a winner and then we have to work really hard at making sure functionality gets added to the winner. That's expensive. I'm not sure there's a lot of value add there. What I would really like to do is we're going to have to pick some of the heavy duty tools. We're going to have to fund them for a while, probably forever in our world here, right? But there is a group of tools that I really want to open up to the open source community. And I've been working with OpenScapes of how we can maintain those tools used in the user community. How do we expand those tools? We also have a lot of tools that really they're so specialized, we're just going to link to them. and we'll keep linking to them until there's a security problem with them. We're not going to maintain them, right? So that's kind of what we're talking about with tools. But everything that we can save is going to go into what kind of tooling do we need for our future? How do we expand our visibility to multiple data sets? Right? Right now, you have to kind of work with the DAC to know what the data set is. What if you didn't have to do that anymore? What if you just did a boundary box and you got all the data that you're looking for? Okay, controversial. You might lose the tools you love. But I'm also not one to get rid of capability until we have something better to go to.
There's some other questions here. I think this is really for Doug. It says, does Worldview support visualization in the vertical dimension? Hello, Doug. Does Worldview support visualizations in the vertical dimension?
It does not. And that's one of the things that FCX looks very appealing in that area. So, yeah, either we keep that capability or we incorporate into a different tool, which will probably mean using the same technologies and the same expertise to get it into the other tool. I don't know how many data sets would leverage that kind of capability. That's the sort of metrics we need to gather. What is the impact of this particular piece of functionality on the user community? And that would be answered by how many data sets would benefit from this and how many users of those data sets. All things we haven't gathered yet.
And there's another one from the Slido for, I think, mainly for Rupesh. It's how does TESVIS differ from Appears?
So TESVIS has 3 sets of tools. The first one, global subsets, works just like Appears. Like you submit the order and then you wait for it and you get the order back after a while. But the second 2 sets of tools, the web service and the fixed size tools, gives the subset data instantly, which might be a different use case. Like I haven't seen other tools does that kind of thing except Giovanni, I think. But so that's the difference between TESVIS. And they also differ on the what data are available on each of these tools. Like Chris pointed out, like they are all limited by what data are there. Yes, it takes a little bit of time to put the data into the system, usually for Appears and for TESVIS and for all other tools as well, because they each have their own requirements for quality flags and what science variables are important and so on. Thank you.
And there are several in the Slido about merging FCX and SOOT or various versions of axing essentially that same question. So I think some of the conversation we've had kind of addresses that, but Morgan, Jeffrey, do either one of you want to talk about thoughts, plans there? There's also one about leveraging CMR metadata for FCX. And then also for FCX on its access is FCX generates. It seems FCX supports data generated by multiple agencies. Or how are you ensuring there are other agencies are aware of the tools? I'm not sure.
Okay, let's see if I can go in order here. So with the one with the SOOT, I know Morgan and I have had conversations. In fact, we were talking with Sarah Lupkin. This dates back all the way to like 2024 in terms of wanting to start bringing a lot of this together. So the goal is there. So now we need to figure out what would that workflow even look like, and how would we try to combine that stuff. I remember the other one was talking about we have data sets from multiple agencies, things like that. Typically, they're aware of it because these are data sets that were formally archived at the DAC. So we haven't gone out and just kind of grabbed someone's data and said, okay, let's put it in FCX. Typically, we're working with the individuals. They're aware of the efforts that we're doing. And I think there's a middle one in there that I might have missed.
Does FCX leverage metadata?
Oh, CMR. I'm trying to remember correctly off that. I know we've done some work to try to leverage CMR in the past. Unfortunately, that is more on the development side, so I cannot speak specifically to that. But I know that has been part of our conversations of how do we. I think it's been part of a larger conversation of how do we go from what we're doing right now, which is kind of isolated in GHRC, and how do we kind of step outwards and become a broader project than what we are right now.
Or just worded. There's one in there about any reason why SOOT couldn't work with other suborbital data, for example, water samples or in-situ soil moisture measurements. Other air path data.
Yeah, I guess the short answer is no. There's no reason why I couldn't. The long answer would be we would probably have to change the way SOOT works on the back end a little bit in terms of metadata, or like how it would display on the map to functionally make more sense for that type of data, since we're coming from an atmospheric perspective. I imagine data users from other fields are going to want to know or see things differently. But I think the short answer is no. I don't see any reason why you couldn't.
One more.
Okay.
It's about is the code open source, or how do you consider open source in terms of community members can contribute?
It's not open source, and that's really not a question I can answer. I'm sorry. I'd have to ask the developers about that.
Okay, there's another one that I'll read in the microphone, so I'm not sure. Process it fast. It seems not merging tools means we replicate services. These are often siloed from learning from each other, and it adds confusion for users as to which to choose. How do we view the trade-off in funding multiple tools that do similar things versus merging versus expanding capabilities with flat funding? Does anyone want to answer that? How do we view the trade-off of funding multiple tools to support similar things versus the resource price for merging or expanding capabilities with a flat funding?
That's something I struggle with every day, right? So let's add in the cost of archiving data that keeps getting bigger and bigger. So they're all stressors on each other. I think the way you approach that, though, is you find the tools that are the most used, you maintain those, right? But you focus really on developing the newer tools, right? Because I just don't see the current group of tools helping us solve future problems.
Right. So what about the tools that are valuable, very valuable and needed by a subset of our users that may not be a big amount of users, but for them to look at that data, these tools are essential. So I'm thinking maybe something like open altimetry that is used for ISAT data. That's probably not a good example, but it could be used for other altimetry data or something unique to the suborbital community.
Right. So let's be honest here. We have not developed a rubric of what tool will be supported, what tool will go to OpenScapes. We have to come up with a fair and transparent way of saying which tools we'll keep. It can't be the only way of being maintained is it has a lot of users. So if something is unique to a special group and needed, I still think we should be maintaining that. But yeah, but there's a lot of decision making in front of us, and we have to figure out a way. And I'm hoping a lot of folks in this room will help us develop this rubric of what do we maintain in house, what do we do through the open source world.
So I'm probably going to make a lot of people mad here, but I come from a community where the community its tools, and I've watched for a long time across very, how should we put it, dependent as this to do the work that my I think it's time for the community to understand that point, that money is not going to keep flowing to do all kinds of things. And I think there needs to be an understanding that at some point the community has to step up and say, this is what we need. We're going to take the owners to start to develop it. And that's just me being realistic here on what's going to happen within the financial and government issues going on with what we've got. We've got our primary job of ingest, archive of data. That's continuing to explode. That's going to continue to cost more money. Money is not something that just continues to increase. So at some point, things have to be able to take apart and leave so that you can continue your core job. So that's just my thoughts here.
Very, very briefly, we're ready to go.
Make sure it's clear from the ESIS perspective, we do have a priority of how we fund things. Our number one priority is always going to be to maintain the archive and archiving new sets of new data, right? Towards, go down a couple of steps, then we have tool development. So really our number one priority is to maintain the archive. Our budgets are not increasing like our size is, right? We just got to be smarter.
Yeah. Okay. I just want to thank everyone. I'm sorry, we're a couple minutes over. If you have a moment and an interest to fill in the little retrospective, little canvas some on the side of the Miro board, we'd appreciate that for your thoughts on how the session went. I also want to thank Bobby for our support in running all of the things for this to happen. And remember the unconference stuff going on. So take a look at that and just thank you, everyone.